Hello everyone, this is a recorded lesson for section 1.3, which is measuring and constructing angles. So the objective of this lesson is to name and classify angles, and also to measure and construct angles and angle bisectors. So before we get into this lesson, what I want you to think about is, what is an angle? Okay, you hear it all the time. I'm sure you've seen and dealt with angles in your math class in grade school. So the definition of an angle is a figure formed by two rays or sides with a common endpoint called the vertex. So just to kind of refresh your memory, okay, we have a ray has an endpoint and goes on forever. Okay, so that's an example of a ray. Now, an angle is just made up of two of these rays. So it could go over here, okay, it could go over here, it could go down here. Okay, as long as it's made up of two rays, that forms your angle. Okay, so your vertex is the endpoint of your angle. So if here's the angle that I'm constructing, okay, this is your vertex, okay, or the plural, vertices. So you can name an angle several different ways. You can name it by its vertex, by a point on each ray and the vertex, or by a number. Okay, so let's look at an example of that. So here we have an angle here. We can classify this a couple different ways. Okay, we can name it by its vertex, which is just angle R. There's its vertex. We could classify it by 2 points and the vertex. We can call this angle SRT. We could call it angle TRS, or we can classify it by its number. Okay, we can call this angle 1. Okay, just in terms of your vocabulary, the set of all points between the sides of the angle is called the interior of an angle. The exterior of an angle is the set of all points outside the angle. Okay, so we cannot name an angle just by its vertex if the point is the vertex of more than one angle. So if we were to look at this angle right here, and this was Q, we'll call this R and S. And I also had another ray coming out from the vertex, and we'll call that T. Okay, I can't call this angle Q because I don't know which angle I'm referring to. Am I referring to angle SQT, or am I referring to angle SQR? So that's why in this example we could classify by its vertex, because there's only one angle. Okay, there's one vertex for one angle. So here's your first example. A surveyor recorded the angles formed by a transit, which is point A right here, and 3 distinct points B, C, and D. So what I want you to do is I want you to name 3 of the angles. Now there's a couple different answers for this. So what I want you to do is pause this recording and actually write out the possible names. Okay, so one of the possible answers, and you might have, again, different answers than me, one of the angles could be called angle BAC. Another angle could be angle CAD. And another angle could be BAD. Okay, these are all the possible answers. Okay, so any of those, so we just name this angle, and this whole entire angle. So let's get into some more vocabulary. I want you to distinguish the difference between the measure and a degree. Okay, the measure of an angle is usually given in degrees. So the degree is part of classifying the measure of an angle. So since there are 360 degrees in a circle, 1 degree is actually 1 360ths of a circle. Okay, so when you use a protractor to measure angles, you're going to apply this protractor postulate. Okay, so the protractor postulate states that given segment AB and a point O on segment AB, all rays can be drawn from O. All rays that can be drawn from O can be put into a 1-to-1 correspondence with the real numbers from 0 to 180. Now let me demonstrate what that actually means. Okay, so here is my drawing of a protractor. Okay, and we have segment AB here. Okay, so that is segment AB, and there's a point O that lies on segment AB. So if we were to draw a ray coming out here, so this is ray OC, that corresponds with C right here. So that looks like it's about 45 degrees. If we look at this ray, okay, ray OD, that corresponds with the measurement of D, wherever that crosses or whether that falls on your protractor. So if I wanted to know, well, what is the measure of angle DOC, I could take the absolute value of D minus C, so that would be 115 minus 45, or, which is 70 degrees, or I could take the absolute value of 45 minus 115 and get negative 7, or well, that would give us the absolute value of negative 70, so that gives us 70 degrees. Okay, so that explains sort of visually what the protractor postulate is stating. So, in terms of classifying angles, again, this is just a review, so I'm going to go through this pretty quickly. An acute angle is an angle that is less than 90 degrees. A right angle is an angle that is equal to 90 degrees. An obtuse angle is greater than 90 degrees. And a straight angle is an angle with a measure of 180 degrees, or a straight line. Okay, they're formed by two rays. So this would be your point right here. All right, so if we look at, again, sorry for my poor drawing of a protractor, but if we look at this protractor, we're looking at the different angles here. So the first one I want you to find is the measure of angle WXV. So that's this angle right here. Okay, so we take the terminal side, which is this right here, V. Okay, and we see that it opens up, because it corresponds with this point right here, this degree. It opens up at a 30-degree angle. So this angle would be acute. If we look at I want to know what is the measure of ZXW. So I'm looking for this angle right about here. So this is we're going to be applying the protractor postulate. So this looks like this ray goes through the degree of 120 degrees. W crosses through the 30-degree mark. So I can take the absolute value of 120 minus 30, or 30 minus 120 degrees. And we can do it once, of course. So 120 degrees minus 30 degrees gives us 90 degrees. So this is actually a right angle. Congruent angles have they're angles that have the same exact measure. Now in terms of notation, okay, you see this here. Okay, this is a standard equal sign, but when you're talking about congruence, you have a little squiggly line on top. So equals, the equal sign is used to talk about the measure of angles that are equal, which is the definition of congruence. And congruence is when you're referring to two angles that have the same measure. So if we look down here at our angles, we have angle ABC is congruent to angle DEF. And the reason why we can make that statement is because the measure of angle ABC is equal to the measure of angle DEF. So it's important that you understand the difference here of when you're using an equal sign and when you're using a congruent sign. An equal sign is used when you're actually referring to a value, and the congruent sign is when you're talking about congruence. So here's another postulate for you. this is the angle addition postulate. So if S, right here, is in the interior of angle PQR, then the measure of angle PQS, so this angle right here, the measure of angle PQS plus the measure of angle SQR is equal to the entire angle. Okay, so again, we have this ray here, QS, that's going through the interior of angle PQR, so we can add up each of the angles, and that will give us the measure of the entire angle. So let's apply that. So we want to find the measure of angle FEG. So we're looking for this one right here, FEG. We're told that angle D, the measure of angle DEG, so this whole thing is 115 degrees. And the measure of angle DEF, so DEF right here, I'm going to do it in a different color, is 48 degrees. So we want to know what is the measure of just this white part, angle FEG. So how can we do this? So we know the entire angle is 115 degrees, so I'm going to apply the angle addition postulate because I know that this entire angle is made up of DEF and FEG. So if the whole thing, so let me write that out for you. So the measure of angle DEG, and I'm just showing you the angle addition postulate, is made up of the measure of angle DEF plus the measure of angle FEG. So from this point, I'm just going to substitute and solve. The measure of angle DEG is 115. And I'll do that in green so we can distinguish here. That's 115 degrees is equal to the measure of angle DEF, which is 48 degrees, plus the measure of angle FEG, which we don't know. So you could use a question mark or you could use X or whatever if you want to use a variable. Okay, I recommend using X. So I want to solve for X. So what I'm going to do is I'm just going to subtract the 48 degrees, and I end up with the measure of angle FEG is equal to 67 degrees. And we found that using the angle addition postulate. So it's important to remember the names. More so, I want you to know the concept of these postulates and what they're actually telling us. But when we get into proof writing a little bit later on, it's important to know what postulate and theorems you're referring to. Okay, the last vocabulary that I want to go over is angle bisector. An angle bisector is a ray that divides an angle into two congruent angles. So here's the notation. They tell us right here in this diagram that ray JK, and I'm not just kidding, the ray JK bisects angle LJM, which is this entire angle. Thus, we can conclude from the definition of angle bisector that angle LJK, which is right here, is congruent to angle KJM. And notice I'm using the congruent statement, so I didn't put an M here for measurement because I'm actually talking about the congruence of these two angles, not the measure. We know that the measure of them are equal by definition of congruence. So we look at this example. We know that KM, ray KM, which is right here, bisects angle JKL. So what does that tell us? We know that this is equal. We know that these two are congruent, despite my poorly drawn figure. So we take the next piece of information. The measure of JKM, which is right here, is 4x plus 6 degrees. and the measure of angle MKL, which is this, is 7x minus 12 degrees. We want to find the measure of the entire angle. So what I'm going to do is I'm going to shrink this a little bit. Give me a minute. Bring this over here. Hopefully you can still see it. So what I want to do is I first need to solve for x. Okay, so I know that these two angles are congruent, so I'm going to set their measurements equal to one another. So 4x plus 6 is equal to 7x minus 12. Now I'm going to solve for x, so I'm going to add the 12. I'm going to bring all my constants to one side and all my variables on the other. So this side I'm left with just 7x. This side I'm left with 4x plus 18. I'm going to subtract my 4x. And I'm left with 18 equals 3x. So I'm just going to divide by 3, and I get x equals 6. I will tell you this is a very common mistake. On tests and quizzes, a lot of students stop right here. They say, oh, I solved for x. But we have to really think about what the question's asking us. Okay, they want to know what is the measure of the angle. All we found is x. So what we have to do is we have to plug that back in. To figure out what the measure of angle JKM is, I'm going to plug 6 in for x. So that came from right here. And I get 24 plus 6, which is 30 degrees. I don't have to plug it in to the other because I know that they're going to be congruent, so I know it's going to also be 30 degrees. But just for the sake of checking our work, I'll plug it in. 7 times 6 is 42, minus 12 gives us 30. So each of these is 30 degrees, so that means the measure of our entire angle of JKM is equal to 60 degrees. Okay, so that's it for this lesson. You will complete, it's posted on Moodle, you will complete a couple of the practice problems just to test what we went over in this lesson. Okay, please Moodle message me with any questions.